Alright, let's go ahead and take a look at these problems. These problems involve the inverse tangent. Recall the domain of the inverse tangent is all real numbers. The range is negative pi halves to positive pi halves, not including negative pi halves or positive pi halves. And the function which arctangent performs is it's given an input, and that input is a ratio of a y-coordinate and an x-coordinate of a terminal point corresponding to a real number between negative pi halves and positive pi halves, and it outputs for us that real number, whatever it might be. So here we have the inverse tangent of -1. So -1 is a ratio of a y-coordinate and an x-coordinate of a terminal point corresponding to a real number between negative pi halves and positive pi halves. So to evaluate the inverse tangent of -1, we could think about the unit circle, and we could think about terminal points corresponding we can think about real numbers corresponding to a terminal point whose ratio of coordinates is equal to -1. And if we consider this real number, negative pi force, whose terminal point is positive root 2 over negative root 2, positive root 2 over 2, comma negative root 2 over 2, we can see that the ratio of these coordinates is -1. And for this reason, we can say that the inverse tangent of -1 is negative pi force. Note we could also have thought about the idea that the tangent of negative pi force equals -1, and negative pi force is a number between negative pi halves and positive pi halves. So using that fact and the fact that the tangent of negative pi force is -1, we could say that the inverse tangent of -1 is negative pi force. Let's go and look at B, C, and D. We'll evaluate these compositions, and then we can write a couple of theorems about compositions of tangent and arctangent. Here first we want to look at the tangent and the arctangent, arctangent of the arctangent of root 3 over 2. So to evaluate the arctangent of root 3 over 2, we need to find a real number corresponding to a terminal point whose ratio of y-coordinates and x-coordinates is root 3 over 2. So see the real numbers that correspond to the real numbers between negative pi halves and positive pi halves correspond to terminal points here in quadrants 1 and 4. So we really don't even need to draw that second half of the circle if we didn't want to. In any case, we could look at the real number pi thirds, who has a terminal point of 1/2 comma root 3 over 2, and we could consider that this ratio of root 3 over 2 and 1/2 is exactly equal to root 3. So we can simplify this composition as the tangent of pi thirds. And now the tangent of pi thirds is just the ratio of the y and x coordinate of the terminal point corresponding to pi thirds, which we can see is just root 3. So we find our solution, root 3. For C, we have the inverse tangent of the tangent of 3 pi force. So we start with the tangent of 3 pi force. We can note that the tangent of 3 pi force, well, that is the real number 3 pi force, and it corresponds to the terminal point, negative root 2 over 2, comma root 2 over 2, whose ratio of y and x coordinates is -1. So we're evaluating the inverse tangent of -1, which is actually something we've already evaluated. We found this to be negative pi force. So we can say here that the tangent, or the inverse tangent of the tangent of 3 pi force is equal to negative pi force. Cool. And finally, finally for our compositions, let's look at inverse tangent of negative pi force. So we start with the tangent of negative pi force. We know the tangent of negative pi force is -1, so we have the inverse tangent of -1. Again, we've already computed this. This is negative pi force, and we find our solution then. The inverse tangent of the tangent of negative pi force is negative pi force. So again, let's go ahead and just note some theorems we could write for the tangent and the inverse tangent. We can say that the tangent of the inverse tangent of x equals x for all x within the domain of tangent, which is all real numbers. We could say that the inverse tangent of the tangent of x equals x for all x in the range of inverse tangent, which would be the values between negative pi halves and positive pi halves, not including their endpoints. And finally, that the inverse tangent of the tangent of x is not equal to x for all the x outside the range of the inverse tangent, for all x belonging to real numbers outside, or take away those real numbers in the range of inverse tangent. All right, let's go ahead, and again, I would encourage you not to maybe memorize these theorems, but just to always evaluate step by step those compositions of trigonometric functions and inverse trigonometric functions. Let's go and look at E, cosecant of the inverse tangent of negative 1 over root 3. So to find this value, we can note that for the real number, negative pi sixths, it corresponds to the terminal point, root 3 over 2, comma, negative 1/2. And if we saw the ratio of negative 1/2 and negative root 3 over 2, that's equal to negative 1 over root 3. And negative pi 6 is a number between negative pi halves and positive pi halves. So we really want to evaluate the cosecant of negative pi sixths. And we recall the definition for the cosecant is 1 over the sine, or 1 over the y value of our terminal point, corresponding to negative pi sixths. The y point, or the y coordinate of our terminal point is negative 1/2, and 1 over negative 1/2 is negative 2. So we can see here our solution, that the cosecant of the inverse tangent of negative 1 over root 3 is equal to negative 2. Let me see all of our solutions.